In our previous video, we introduced indices, and we said that just like that, if the value of we are having a general term x to the power 4 or x to the power 3, this x is the base, and these 4 and 3 are indices. So in other words, as for now, 4 and 3 are the indices. Now today we get to look at what we call fractional indices. Now a fractional index is what we shall refer to as a rational index. Right here, x to the power 4, these 4 and 3 here are indices. But then now the fractional indices is just when these 4 and 3 are taken over by fractions. Like you may see here, that x to the power 2 over 3 and x to the power 4 over 3, the 2 over 3 and the 4 over 3 are what we are calling rational or fractional indices. And the rules or the laws that govern how you interpret the rational indices, how you multiply them, how you divide them, are more or less the same as the rules that we explored in our previous video when we were looking at how to multiply and divide indices. For example, when we are multiplying fractional indices, x to the power p over q and x to the power n over q, when the base is the same, you're going to add the fractions, so which is p over q plus n over m. And in our example, it is well spelled out that a to the power 3 over 4 times a to the power 2 over 3. Because it is multiplication of these two indices, they are having the same base, so we shall add the powers. And so it's going to be a to the power 3 over 4 plus 2 over 4. When we add that to fraction, those two fractions, we end up with a to the power 5 over 4. When we are dividing, it's just like before. When we are dividing indices, if they are having the same base, we subtract the powers. So right here, it's p over q over n over m. In our example, it is a over 2 over 3 divided by a to the power 4 over 3. Because the a is the same base, we shall maintain the base, but what shall we do to the powers? We shall subtract them, which is 2 over 3 minus 4 over 3, and our answer will be a to the power negative 2 over 3. Again, when we are having p over q to the a to the power p over q, this is a fractional index. All this is still to the power n over m. It's the same as saying this times that. So in our example, it is a to the power 4 over 5 times, and all this whole thing is still to the power 2 over 3. So it is this fraction multiplied by that fraction. It is still the same as saying a to the power 8 over 15. A to the power negative p over q is going to be equal to, now for us to remove this negative, we have to find the reciprocal of a. And definitely the reciprocal of a is 1 over a to the power p over q without the negative. And this is well illustrated in our example, that x to the power negative 2 over 3, for us to remove that negative, this is the same as 1 over x, which is the reciprocal of this, 1 over x to the power 2 over 3 without the negative. Or it is the same as 1 over x, everything to the power 2 over 3. Then if it is a over b to the power negative p over q, to remove this negative again, we get the reciprocal of this fraction. So it's going to be b over a to the power p over q without the negative. Just like here, 2/3 to the power negative 4 over 5, to get rid of that negative, we get the reciprocal of this, which is 3 over 2 to the power 4 over 5 without the negative. Now, we are going to be using these laws in solving numbers or in solving these fractional indices in our upcoming videos. Thanks for tuning in. Stay tuned for more of these videos. I encourage you to subscribe and hit that like button and share this video for those who may be in need of it. For Kisembo Academy, this is Arnold Rangakuramya.